In December 2022, the Orion spacecraft came screaming back to Earth from the moon. It was traveling at Mach 32, about 25,000 miles per hour, with temperatures outside the capsule climbing to 5,000 degrees Fahrenheit. Inside, every sensor read normal. The mission looked like a complete success. Then the engineers got a closer look. Once the capsule was recovered from the Pacific Ocean, NASA's team noticed something the computer simulations had never predicted. More than 100 spots on the heat shield had physically broken off. Chunks of it gone. The technical term is spallation, but in plain language, pieces of the shield meant to protect the astronauts had essentially exploded into space. With Artemis II, a crewed mission approaching on the schedule, NASA faced a decision with enormous stakes. Do they tear apart the spacecraft and rebuild the heat shield from scratch? Or is there a smarter way forward? The Orion heat shield is made of a material called Avcoat. It works by design. It's supposed to slowly char and flake away, releasing heat in the process. Think of it like a controlled burn that protects everything beneath it. On Artemis I though, the Avcoat didn't just flake, it cracked and blew apart. After a year-long investigation, NASA figured out why. As the Avcoat chars, it produces gases. Those gases are supposed to escape through the material, but on Artemis I, the permeability of the shield was too low, the gases got trapped inside the honeycomb structure beneath the surface. Pressure built, and then, like a tiny explosion, chunks of the shield were forcibly ejected. There was another complicating factor, the way Orion re-enters the atmosphere. Rather than coming straight down, the capsule performs what's called a skip reentry. It dips into the atmosphere, bounces back up like a stone on water, bleeds off speed, and then dives back in. It's an elegant maneuver, but that first heat soak, followed by a short cooling period, and then a second plunge, created exactly the conditions needed for those gas buildups to become dangerous. The good news was that the heat shield's inner structure stayed cool throughout between 70 and 200 degrees Fahrenheit, so the spacecraft was never in immediate danger during Artemis I. But it didn't fail this time is not an acceptable safety standard for a mission carrying 4 human beings. NASA's human rating requirements are among the strictest of any engineering standards on Earth. They needed a real solution, not reassurance. Here's the problem. The Artemis II heat shield was already built and bolted onto the spacecraft. Replacing it would mean years of delays. So NASA's engineers asked a different question. What can we still change? The answer turned out to be the trajectory itself. By adjusting the re-entry angle to be slightly steeper and shorter, NASA can reduce the time Orion spends in the most intense heat zone. Less time in the heat means less time for gases to build up and less risk of those violent pressure releases. The trade-off? The crew will experience higher G-forces during re-entry. That's not nothing, it's physically demanding. But NASA determined it falls within safe limits, and critically, the heat shield has enough material thickness remaining that even if some spallation does occur, it stays within a predictable, manageable range. In other words, they know the problem, they know why it happens, and they've engineered the mission around it. Artemis II will carry Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen on a 10-day journey around the moon, the first humans to travel that far from Earth since Apollo 17 inches 1972. Their safe return now depends not just on the heat shield, but on the year plus of detective work that went into understanding exactly what happened during Artemis I. As the early 2026 launch window approaches, the Orion anomaly is a reminder that every spaceflight is still, in some sense, a test flight. Artemis I revealed a flaw. The investigation turned that flaw into knowledge, and Artemis II will prove that NASA can adapt even when the hardware is already built and the clock is ticking. The heat is coming. This time, we know what to expect. If you love deep dives into space exploration and the engineering behind the missions, don't forget to subscribe to our channel. If this video helped you understand the challenges of the Artemis program, hit that like button and let us know your thoughts in the comments. See you on the next mission. Stay curious.